Welcome back, dear students. In the last session we solved question number 1 and 2 of exercise 2.2. Hope you all remember it. In these questions we just substituted the given values in the polynomial and we got our answers. Hope you remember it. Now let's proceed with the next question, question number 3. In this question he is asking verify whether the following are zeros of the polynomial indicated against them. So what do you mean by zero of a polynomial? Let's have a look. Zero of a polynomial is nothing but the solution of a polynomial. Okay, the other name of zero is solution, or you can call it as a root, or you can call it as a factor, or zero. These all are the names of solution. So every polynomial has a solution, right? Like in previous classes you have done linear equations in which you have done different polynomials like 2x plus 4 is equal to 0. So what is x value here? 2x is equals to minus 4. X will be equals to minus 4 by 2, that will be minus 2. This is just an example to explain you what I mean by solution. Okay, so when you substitute this value, that is minus 2 is solution of this now. Okay, we found the value of x, so minus 2 is a solution of this polynomial, linear polynomial. Okay, or it can be called as a zero or a root or a factor of this linear polynomial. Now how to verify why it is called zero? Let's have a look. So we'll substitute x is equal to minus 2 just to verify our answer. So in place of x, what will I put? Like we were putting in question number 1 and 2, we were putting the given values in the polynomial in these two questions. Same thing we have to do here. Put x is equals to minus 2, you'll get 2 into minus 2 plus 4. So 2 times is minus 4 plus 4, and final answer is minus 4 plus 4 is 0, right? So this is the reason this is called zero of a polynomial, because when you substitute this value, the solution in the polynomial, you get 0. If it is not a solution, like if I take any other value here other than minus 2, 2x plus 4 is our equation, right? 2x plus 4 is our equation. Other than minus 2, other than this solution, if I take any other value, I'll not get 0. Like let x is equals to 3 suppose, so I'll not get 0 here. 2 into 3 plus 4, that is 6 plus 4 is 10. It will not be 0 because this is not a solution or a 0 or a root or a factor of this polynomial. So we are going to follow this procedure and solve question number 3 and 4. Let's have a look at the first bit of question number 3. So one thing you should keep in mind, if it is a 0, if x is equal to minus 3 is a 0, then the answer will also be 0. What is the other name of 0? Factor or a root or a solution. Okay, so same thing we have to do what we did in question number 1 and 2, just substitute the given value in the polynomial in the given equation. In place of x, what will I put now? Minus 3. Let's begin. Given p of x is 3x plus 1, we'll put x is equals to minus 1 by 3. In place of x, I'll write what? Minus 1 by 3. So this becomes 3 into minus 1 by 3. Yeah, p of x, that is p of minus 1 by 3. So p of this become 3 into minus 1 by 3. In place of x, I have taken minus 1 by 3. Now can I cancel this 3 and 3 here? I can cancel this 3 and 3. 3 ones are 3 ones are, okay. So remains what? Minus 1 plus 1, because this 3 and 3 got cancelled. Minus 1 plus 1 is 0. So when you substituted this value in the polynomial, you are getting 0. We can say now, using this concept, as I substituted minus 2 here in the polynomial and I got 0, so I can say this is a solution of a polynomial or 0 of a polynomial. So when I get 0, I can say it is a 0 of a polynomial. In simple words, if I say after substituting the value, if you get 0, it is a 0 of a polynomial. If not, it is not a 0. So I can say, since p of minus 1 by 3 is equals to 0, minus p of the x is equal to minus 1 by 3 is 0 of the given polynomial. So this way we proceed and solve all the bits. Let's see the second bit now. 5x is equal 5x minus pi. This is a polynomial and the given value is 4 by 5. So substituting 4 by 5, where do we substitute 4 by 5? In place of x. So 5x minus pi, in place of x will put 4 by 5. In place of x I am putting 4 by 5. So here 5 into 4 by 5. So what gets cancelled here? 5 and 5 gets cancelled, remains 4. So 4 minus pi, it won't give you 0. So since p of 4 by 5 is not equals to 0, this is not a 0, so I can say this value is not a 0 of the polynomial. Okay, so with these two questions you can understand this whole bit. If you get 0 as answer, then you can write it is a 0 of a polynomial. If you get non-zero value, any value other than 0, then you can say it is not a 0 of polynomial. Okay, we proceed in the same way for the other questions. Here you can see we have equation p of x is equal to x square minus 1 and x is equals to 1 and minus 1. We have to check whether x is equals to 1 and minus 1 are zeros of this polynomial. So we'll check both for both the values. First I'll put 1 in x in place of x. What will I get? 1 square minus 1. Okay, 1 square is 1 minus 1, that is 0. So what can you say for this? You can say that 1 is a 0 of this polynomial because your answer is 0. Okay, we can say that 1 is a 0. Next, let's check for minus 1. Let's check what will be the answer for if you substitute minus 1 in place of x. So what will you get here? Minus 1 square. Yeah, I'm putting minus 1 in place of x. So minus 1 square is 1, right? Yeah, I said you before also. Minus 1 square is 1, minus 1 into minus 1 is plus 1. 1 minus 1 is 0. So what can you say about this again? Yeah, this is also a 0. So we can say both 1 and minus 1 are zeros of this polynomial. Okay, so this is the way we proceed and simplify all the bits. Here we have to check whether minus 1 comma 2 are zeros of this. So first I'll substitute minus 1. I get a 0 here, simplifying it. Then I substitute 2. I get a 0 here. Okay, so these both are zeros of the polynomial. Okay, you can simplify it. Now let's check for the sixth bit. Try the fifth bit in the same way. Okay, how we have done the first, second and third bit. Now let's see the sixth one. It's in variable form. The given polynomial is lx plus m. Okay, lx plus m, and the given value of x is minus m by l. We need to put minus m by l in place of x and check whether this is a 0 of the polynomial or not. So let's take the polynomial, given polynomial, and putting minus m by l in place of x. I am putting minus m by l in place of x wherever x is there. So I am getting l into minus m by l plus m as it is. Now this l and l gets cancelled, remains minus m plus m. So minus m plus m is 0 again, right? What can you say about this? Yeah, as we are getting the answer as 0, we can say minus m by l is a 0 of this polynomial. Oh, okay, so there is nothing difficult here. Now here we have another question.